Well, who's ready to get started? Let's hold up our hands if we're ready to get started doing some kitchen chemistry. Who's in? All right. So my name is Brian Jones, and I'm here with the Little Shop of Physics, and this is LSOP Live. And today we're going to be doing a bunch of stuff on kitchen chemistry, and I'm going to let my compatriots introduce themselves. So who else is here today?
Hi guys, I'm Brenna. I am a student intern with the Little Shop of Physics, and I'm so glad you guys are here.
Hi, my name is Maud, and I'm also a Little Shop of Physics intern here. I'm also super excited that everybody's here.
And we're going to show you a whole bunch of stuff that you can do with materials that you probably already have in the house. These are things you can probably find in your kitchen, and I'm going to start with one where we need something a little bit special. I have pieces of paper here. These pieces of paper made out of potato starch. We got edible paper, and you can get it at the craft store. And just to prove it's edible, it tastes bad. I'm not saying it's a good idea to eat it, but you can. In this jar, I've got some water plus some saliva. I was collecting my saliva for quite a while as we were warming up here today. And I'm going to take a bunch of these pieces of paper and I'm going to put it in here. And this is going to relate to something we'll talk about later. So a bunch of the potato paper is going in the jar with the saliva. And then I'm also going to take some pieces of paper and put them in this jar, which just has water in it, okay? Just has water in it. There we go, and I'm going to swirl them. And we're going to let them sit for a while, and then later, when I come back, something very different is going to have happened to these two containers. And Maud has got something she's setting up with this as well.
So I've got what Brian had earlier. It's just a little piece. It's a bigger piece of that potato starchy paper. What I've got here is some of what your parents might have if you have pets at home. It's just a carpet stain cleaner. So when your dog or cat or whatever pees or vomits on the rug, this is usually what they'll use. It's just a pet stain cleaner. And I'm just gonna spray this paper up, and we'll come back to it later to see what happens.
All right, and then we're going to start by doing some experiments with acids and bases. And what's in this container? There's a little bit of a chemical. It's called bromethymol blue, and actually you can get it. You can get this stuff at the drugstore. It's not a common thing, but this is something you can get, and science teachers probably have something like this. Well, this chemical changes different colors with acids and bases. And so I'm going to show you a quick demonstration, and then we'll show you some things that you can do in the kitchen. So right now, this is blue, but if I blow into it, I'm exhaling carbon dioxide, and the carbon dioxide combines with the water to make carbonic acid. And one breath, we got a color change. Was blue, now it's kind of yellow, and I can turn it back to blue. I just made it acidic, but Maud's going to hand me a little bit of, oh yeah, a little bit of. I want the other stuff. I'm going to add a little bit of ammonia here, and ammonia is something that you might have in the kitchen for a cleaning compound. And if I take this and I'm going to make it basic, and ammonia's a base, so turn it back from being yellow to being blue. But you might not have bromethymol blue hanging around your kitchen. But I bet you have the stuff that Brenna is going to use next.
Yeah, so you can actually do some of this pH stuff at home. So here I have tea. 2 of them are turmeric tea, and 2 of them are hibiscus tea. And actually these are really good indicators of pH. So I have some baking soda here, which is a base, and I'm going to add them to both teas just so you guys can see the color change that we get. So I can add it to the hibiscus tea, and you can see that there's already a pretty dramatic color change.
Like blue.
And the turmeric tea, you can see that it definitely gets darker than the other one. And then I have an acid, which is just some white vinegar. I'm going to add that as well. And as you can see, the hibiscus tea isn't as dramatic, but the turmeric tea gets quite a bit lighter. So these are two teas that you can easily buy at the grocery store or a drugstore, and you can do this pH experiment yourselves.
The coolest tea is some tea that Maud has. And Maud, what kind of tea do you have?
So I have this butterfly pea flower tea, and what's special about this tea is that the color changes are super, super dramatic. So it's already just such a beautiful, beautiful blue color. And if I go in with something basic like ammonia,
Whoa. That turned green.
it turns pretty drastically different color. And if I go on the other side, put in something super acidic like vinegar, which you can do this with lemons at home as well,
Whoa.
that changes to a lovely pink magenta like color. And there you go. You got
That is awesome. So that has got an awesome, awesome color change. But if you don't have any of the pea flower tea, Brenna's going to show us something else that you can try at home.
So this is pretty exciting because you can actually make your own pH indicator just like Brian's bromothymol blue at home. So all you need is a red cabbage, which these are super cheap at the grocery store. You can have one of your parents pick up one. And what you're going to do is you're going to boil pieces of this cabbage. So if you just pour boiling water over the cabbage, you're going to end up with something that smells bad, but you end up with a liquid that looks like this. Now this is actually your indicator once you strain off the cabbage. So I have my indicator in a jar here, and you can actually make a whole pH scale with just basically cabbage water. So I'm going to take some, and you can use a straw as a pipette. You actually don't need a pipette if you don't have one at home. I'm sure you guys have done this in a drink before, but I'm going to add cabbage juice to each jar. And then we're going to add our same acid and base as before. So baking soda as our base, vinegar as our acid. And I kind of have the pH scale behind it just for your reference. It's not going to be exactly the same, but. Alright, now here's the fun part. So I have baking soda here. I'm going to take a small scoop. I'm going to add it to this one. And as you can see, it turned blue almost instantaneously with the addition of that base. And now, for the vinegar, look at that.
That is awesome. That's pretty.
Yeah, so you guys can do this at home. You can try all different sorts of acids and bases in your kitchen, and you can get a pretty nice rainbow using this homemade indicator.
Those color changes amazing. I think that the cabbage is the best, isn't it? Love it. And you can try this. Just a little bit of red cabbage. Brenna cooked it up and made an awesome indicator. Oh, well, we'll try to speak up. We'll try to speak up a little bit. We'll try to speak up a little bit more when we're talking. How about that? Next piece of the puzzle is we're going to do some stuff with water and oil. So I'm going to turn over here to Maud. Well, actually, yeah, we'll come back to the enzymes piece. So next up is, oh, sorry, highlighter. Totally forgot. Sorry. We have one more acid-base thing to do.
All right, so we all have highlighters at home, and here I have just an old brochure from so if you're just renting a textbook or something, here we go. Do some yellow, get some green in there. And if we take a lemon, it's actually super cool. You can erase the highlighter. If I just go back over the yellow and the green, they both just basically disappear right off the page.
So a lemon is a highlighter eraser. That is
Yep.
awesome. And this is an acid-base thing. It turns out that the color in the yellow highlighter, it's a pH indicator, and it turns clear when it turns acidic. And so you're able to use a lemon to erase that yellow highlighter. Awesome, awesome. That was fantastic. And I think we're gonna, is that a wrapping up pH? I'm looking at my thing. Oh yeah, and now we're up to the ice and the oil thing, right? All right, so we're over to Maud, and this is something that's a cool mixing thing. And you guys know that oil and water do not mix.
So, in this tall glass here, I've just got a bunch of canola oil. What I'm going to do is I'm going to pick one of these handy dandy ice cubes, which are just colored with some like red gel food coloring. And if I drop it in there, so
Silvery, which is super cool.
yeah, and so water is denser than oil, but ice, well, it's kind of floating, but you can see as it melts, the water is denser than the oil, so it'll sink to the bottom, and you'll get these little droplets. And it'll just continue to melt. We can come back in a little bit to see bigger droplets. The ice is acting a little heavy right now, but
Awesome.
yeah, we can come back
awesome.
later and see what it looks like completely melted.
And then Brenna is going to do another thing with water and oil. And this is something you don't think about with oil, but it just got a little light table going on, which is kind of awesome.
Yeah, so this light table is just so you guys can see it better, but you can definitely just use a regular old flashlight at home. So extracts, like mint extract or orange extract or any of those, they are actually a mix of oil and alcohol. And the oil kind of mixes in with the alcohol pretty well, but when you put it in water, the alcohol can't hold on to the oil anymore. And so, can you see it, Brian? What happens is you get this really cool cloudy effect. And it gets, you can see it gets pretty cloudy, but if I add just regular dish soap likes to break down oils, that's why we use it. It will become almost clear again. I can just mix this here. Oops, use my straw. You can see it cleared up quite a bit from that cloudiness that it was before. So this is why washing your hands is important, because cell walls are made out of oily stuff, just like this. So when you wash your hands, it breaks it down, they wash down the drain, and then they're gone.
Awesome. So that was a little bit of mint extract and water. It made this cloudiness because the alcohol dissolves in the water, liberates little droplets of oil, works like a cloud, and then the soap kills it, which is an awesome thing. Speaking of things which will kill things, this was the container with the potato paper in it that also had saliva in it, and that paper is gone. Here's the paper in just the container with water in it, and if you can see, the pieces of paper are still floating on top. This one definitely have pieces of paper, and this one I don't. And what's making that happen is this. When you eat food, it actually starts digesting in your mouth. And in your mouth, you have enzymes, and one in particular called amylase. And what the amylase does is it just carves up the molecules, the long molecules that make this potato starch paper all together, but breaks up those starch molecules, carves them up into tinier molecules, sugars, that dissolve in the water. And so this paper is digested. It is full on digested, whereas in the water, it's not. And so there was clearly something going on in the saliva. And what's happening is enzymes. Those are enzymes, and you can show those at work. And that all I needed was a little bit of that potato paper and a little bit of saliva, which I collected before the presentation. And then Maud has got...
All right, so if you remember what that paper looked like at the beginning when I first sprayed it with everything, now it's just basically goo. And like Brian said, it's been essentially digested because what's in that pet cleaner is just a bunch of enzymes that can break down bodily fluids from animals. And that is just essentially what happened here to the paper, and it's just goop now.
Just goo. So the enzymes in there actually dissolved all the starch in the paper and turned it into a nice plate full of goo. Work the same way as in the saliva, and actually in this case, it's the same enzyme. It's amylase. So here's the interesting thing. Certain stains that you get, you can use enzymes to clean them. And one way you can get enzymes is to get stuff from the store. The other way you can get enzymes is in saliva. And so I do this sometimes. Some kinds of stains, I can put a little saliva on it. That can help. It's kind of an amazing thing because you have stuff in your saliva that exists in cleaning products. No need to go to the store. And next, Brenna's going to make something edible right here. And this is another kind of like reaction where we're going to catalyze something happen. In the milk, there's some molecules, and Brenna's going to do something to them.
So I'm not going to eat this because I don't want to. But here I just have some whole milk. It's in this little thingy. And actually, if you add vinegar to whole milk, you will start to make it curdle. So I don't know if you've ever seen spoiled milk, but spoiled milk is curdled. It's chunky. This isn't going to be as dramatic, but you can actually make cheese. So I'm just going to stir up my milk and vinegar concoction here. And as you can see on the spoon, there's some chunkiness. It's very appetizing. And then I'm going to take this cloth, which this cloth has lots of little holes in it. I'm going to put it over another container, and I'm going to pour my milk through. And when I pour my milk through, I get the chunks separate from the milk, and that's my cheese. And you can actually eat this cheese. I'm going to make Brian eat it because he's more brave than I am. But I can squeeze out the liquid milk. Maybe.
And you can see what's coming out of the bottom. It's a lot more clear. It's a lot more clear.
So if I squeeze it out, we're almost there. All right, and then I open it back up. I have this delicious looking cheese that I am going to pass to Brian, and he is going to prove that you can eat it.
So you can see, oh yeah, and you can, this is cheese. This is just a really soft cheese. Now, eat it, they're saying, okay. It tastes like cheese. It tastes like cheese with a little bit of a vinegar aftertaste. And if you want to make it taste less vinegary, you can wash it. So this is one that got a lot of reaction. Someone asked Brenna to review the instructions for this one. How do we make that go?
Alrighty. All you need is whole milk and some vinegar, which I am out of. But you can just use distilled white vinegar and mix them together. Wait till you see those little chunks. And then you pour it through a holy cloth like you saw Brian eating it out of into another container. I wouldn't drink this if I were you, but definitely you can eat the cheese. So.
And it turns out what gets left behind is all these solid elements. We've curdled the cheese, and you can see the liquid that was left over is a lot less cheesy. And then I'm left over with this, it's a soft cheese. And if you wash it, it doesn't even taste particularly vinegary. And this is a chunk here that's tastes like cheese. Kind of a vinegary flavored cheese, but you can eat that just fine. Is it good? No. I wouldn't say it's good. But if you wash it, there are cheeses that get made pretty much like that. And I would say you certainly don't have to eat it, but it's an interesting process to make this go. Next up, we're going to do something with oranges? Is that what's up next? Oh yeah, over to Maud. Maud's got 3 balloons and an orange. What's next?
Alrighty, so as I'm sure you've all had oranges before, when you peel it, sometimes you get that weird little spray that comes into the air. So that spray is just basically this orange citrus oil, and it pops latex in balloons. And so if I'm just gradually making my way through peeling this, you can see that I'm spraying it with the, I'm so scared. Oh my goodness.
So Maud is just peeling oranges, and as she's peeling oranges, there's a little spray. How about the green balloon? That one looks a little
weaker.
plumper.
Alright. Alright, well, and if it doesn't want to pop, then you can always just like try and squeeze some oil out of the peel on there. You know, if you're really brave. Oh my. And if you're brave, you can just go right in there and start, you know, just taking some really oily pieces. And it pops. And I wish I had a pin or a needle to tell you guys that it was fake, but I don't, and it's very scary. But yeah, that's popped balloon with an orange.
So it's the limonene, is an oil that comes out of the orange, and it's what makes that fine spray. And that fine spray, that actually will dissolve the latex of the balloon. This was exactly what you saw. Maud was just peeling an orange next to a balloon, and the balloon pops. And it's the oil that actually dissolves the latex. That is awesome. And now we're over to Brenna for another kitchen chemistry thing. And this is something you certainly have in your kitchen.
Yeah, so if you've ever baked a cake or really anything, you probably have baking powder. And sometimes I know you use baking soda or you use baking powder. But baking soda, you need an acid to work with. So you need to put something like vinegar or something like that in your cake. Baking powder works differently. So I'm going to put it in this flask here. And I'm a little messy, but that's okay. This is chemistry. Chemistry isn't clean. Okay, so I have a good amount of baking powder in there. And then I'm going to get a balloon, which we will use in a second. My funnel. And then I have some pretty hot water. This is just a little bit less than boiling. If I pour it in here, you can see it's starting to fizzle. If I put this balloon over the top, the baking powder, when it heats up, it releases gas. And so, when you use baking powder in a cake instead of baking soda, this is how it works. It heats up in the oven, releases gas, and that's how you don't end up with a cake that tastes like a brick. You can also do the same thing with baking soda, because baking soda and vinegar make bubbles, and it releases the same gas as this does. So this is kind of fun to do at home.
And speaking of bubbles, we have a grand finale for you. And before I do it, I'm gonna ask everybody this. Don't do this unless you're working with your parents. Kids, don't try this. But if you wanna work with your parents and do this, it's kind of awesome, and it's another bubble thing. Now right here, I've got a microwave oven. And inside the microwave oven, I've got a bar of soap on a plate. And this particular kind of soap is Ivory brand soap. And it turns out Ivory brand soap has bubbles in it. It's got bubbles in it. There are little bubbles of air. And it's also got a lot of moisture in it. And so if I heat up the moisture, I'm going to get water vapor. It's going to go into those bubbles, and they're going to increase in size. So I'm going to put a bar of Ivory soap in the microwave. I'm going to give it 2 minutes. And we'll watch it go. And I'm starting to see a little something happening on the sides. Oh yeah, do you see it growing in there? We're going to let that keep going. And now I'm going to open up the oven and let's see what we got. Here we go. Oh yeah, check this out. Here's a soapy foam is what I've got. And basically I just blew bubbles with the soap. When it comes out, it's a little hot. And then you end up with this soapy foam. And this floats really well. If I put this in water, it just floats like nobody's business because it's got a lot of air in it. It's got a lot of air in it. Just kind of an amazing thing. And it only works with this particular brand of soap. And this is not particularly dangerous. Soap's not dangerous. And it actually made my microwave smell really nice. It made the Little Shop of Physics smell really nice, which after all this time of working with ammonia and vinegar and stuff, it was smelling a little not fresh in here. Now that makes it much better. But definitely don't do this unless you're working with your parents and you want to give this a try. Awesome, awesome. That's our grand finale. And the grand finale finished with the thing Brennan was doing. And the thing that, oh, hang on, do we want to look at the water and the oil again?
So now the ice is a little bit less dense, so I just wanted to show you guys what it looks like. If you can see at the bottom, there's a bunch of like these little bulbs of water at the bottom of the oil. But, like Brenna did earlier, if I put some dish soap in there, it breaks up that layer, and if I stir it up, it becomes completely homogeneous, and it's all one big weird milky substance. But yeah, just wanted to show you guys what it actually looks like once the ice is melted.
Awesome. And then two more things we're going to do. First off, I want to thank everybody for taking part. I want to thank Brenna and Maud for being part of this episode because we had a lot of fun in the Little Shop of Physics making this up. I want to thank all the people who are here for joining us on Little Shop of Physics Live. And I want to say this, go to our Little Shop of Physics main page, and I'll put that in the chat again, and then write to us and tell us what topic should we do next. We are looking for your ideas as to what kind of things can we do on Little Shop of Physics Live. And we're going to be back every Friday. We're going to be back every Friday with a new episode, and then we're going to post our completed episodes on our webpage so you can check those out. We've got a page for Little Shop of Physics Live. Let us know what you'd like us to do, but I think our next topic's already picked, and it builds off this. We were blowing bubbles in the soap. Next episode, bubbles. We're going to do all bubbles, and the physics and the chemistry of how they work. Do something with ice cream. We can do that. Okay, we're on order ice cream. We'll do ice cream at some point. Well, not maybe next week, but I guarantee you we will do ice cream. And there it's 11:30. We're ready to wrap it up. I want to thank everybody for joining us. We'll see you next week on Little Shop of Physics Live.
Thanks, you guys.
Bye, everybody!
Bye-bye.